let me just go through this algebra problem that we did yesterday. So if we have A is equal to 1/2 B times H. And we are trying to solve this equation for H. Solving an equation for H means that you want to get the H on one side of the equal sign by itself. So currently we have this 1/2 on the same side as the H, and we have the B on the same side as the H as well. So what we need to do is get those two things over to the other side to isolate our H or get our H by itself. The way I would start by doing that, the 1/2 means that you have a 2 in the denominator. So to get that 2 in the denominator to the other side, we need to multiply both sides of our equation by 2. Because this 2 in the bottom cancels out with this 2 on top. Because if you both multiply and divide by the same number, it goes away. So that would leave us with 2a is equal to b times h. So we got rid of this 2. We still have the 1 in the numerator, but 1 times anything is just itself. So we don't need to write that 1. So now the only thing that we need to move to the other side is this b. So to get the b to the other side, it's currently multiplied by h. So to get it to the other side, we would need to divide both sides by b. We would need to divide this side by b. And what we do on one side of an equation, we have to do on the other side as well to keep things balanced. You can't divide by b on one side and not divide by b on the other side, or that would make it unbalanced. So that would cancel. This b would cancel out with this other b. And we would be left with, on the right-hand side, we would be left with just h. On the left-hand side, nothing cancels because we don't have a b on top to cancel with the b on bottom. So we leave that as 2a over b equals h. And that would be the final answer. Yeah, you bet. What multiplication problem would you like to work on? I think yesterday we did 2 digits times 1 digit. Is that still what you're working on? Okay, sure. So how about let's do 46 times 7. Okay, so if we're doing 46 times 7, I like to put the 2-digit number on top and the 1-digit number on bottom. and line up their ones digits. So you know how 46 and 7, the rightmost number is the ones digit, and then the number to the left of, or the digit to the left of that would be the tens digit. So this number, since it's just a single number, that would be a ones digit. So we're going to line up the ones digits. So we have the 7 directly below the 6. You're doing 10 now? What do you mean by you're doing 10 now? Ah, like 10 times 20. Okay, awesome. So let's back up and do 10 times 20. So if we have 10 times 20, when we have two digits times two digits, it doesn't matter which digit goes on top and which digit goes on bottom. So we'll just line them up. And we start by multiplying the ones digit by every digit on top, the ones digit on bottom by every digit on top, starting with the ones digit on top. So we take this 0 that's in the ones digit, we multiply it by this 0 in the ones digit. 0 times 0 is 0. So we're going to put that in the ones digit directly below the line. The next thing we'll do is we'll take our ones digit of our bottom number, multiply that by the tens digit of the top number. So we go this digit times this digit, then this digit times this digit. So 0 times 1 is also 0. So we put a 0 in the tens digit of the first line, and that line is done. When we move, now we're going to go to the tens digit of the bottom number and multiply this tens digit by every digit on top. But before we do that, when we deal with a tens digit, we want to start by putting a 0 in the ones place of the second line. And feel free to let me know if you have any questions or if you want me to re-explain something a little bit slower. So I put this 0 here to show that we are now multiplying by the tens digit in the bottom. So now when we do 2 times the ones digit in the top number, that number will go here in the tens slot. So 2 times 0 is 0. Anything times 0 is 0. Now we need to do the 2 times the 1. 2 times 1 is 2. And that number, since we filled up this slot, we want to go one more digit to the left. 2 times 1 is 2. So we put a 2 right there. We don't have any more digits on the bottom number, so we add these two lines up. 0 plus 0 is 0. 0 plus 0 is 0. And 2, we don't have any number here, so it's 2 plus 0 is 2. So our final answer would be 200 using this kind of a method. Keep in mind that you don't have to use this method. You can also use like an addition method, because if you have a number times 10, that means to add that number up 10 times. So to do 10 times 20, we could also do 20 plus 20, that's 2 20s, 3 20s, 4 20s, 5 20s, 6 20s, 7, 8, 9, oh, I ran out of room. Let me do it down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can also do the problem in this method of 10 times 20 would be adding 20 together 10 times. So you can go 20, 40, 60, 80, 100, 110, sorry, 120, 140, 160, 180, and 200. So we get the same answer if we use this multiplication like on top of each other method as we do adding the digits together, adding the number together 10 times. Oh, it's a lot of lag going on? Oh, okay. Like a lot of lag in the audio or in the writing? Wow, that does seem like a lot of lag. You still with me? Oh, wow. Interesting. Well, thanks for that feedback. Not sure what to do about that, but I can definitely work on getting the lag time down. Might have to use a different streaming software, I'm not sure. So I'll look into that. Thanks for the feedback. Is there anything else, any other problems that you wanted to work on? While I'm waiting for a response, I can, I did have a request for request for another type of a problem. So feel free to ask another question if you have one, but I'll keep going with another problem that I have. So just 1 second. Alright, so I want to match the following numbered addition statements with the letter of the correct property of addition. So we have 1 is -5 plus 5 is equal to 0. And then we have, or let's just talk about this. So we have -5 plus 5. So this is an example of a problem that we have the negative of a number plus the number goes to 0. That kind of a problem is the identity property of addition. Since the identity property says a plus -a equals 0. So anytime you have a number plus its negative, that goes to 0. Another way to write that is a minus a equals 0. So if you start with a number and you subtract the same number, that's going to give you 0, and that represents the identity property. So number 1 would be the identity property. Going on to number 2. Number 2, we have -16 plus 4 in parentheses, and then plus 5. That is equal to -16 plus, in parentheses, 4 plus 5. Let's put that down just a bit. Okay, awesome. Good to know. Thanks for the feedback. Yeah, absolutely. Let me finish this one first, and then I'll be right back with you to do 1 or 2 more. Can you give me a couple more examples of problems that you're working on? Okay, so this problem, we have the parentheses around 2 numbers here, the -16 and the 4. Then we have a plus 5. These numbers over here are in the same order, but the parentheses is around the 4 and the 5 instead of the -16 and the 4. So that means that the parentheses is showing that these 2 numbers are associating with each other, and now a different 2 set of numbers is associating together in this parentheses. So we call that the associative property. And to write that out in letters is if we have A plus B inside parentheses and then plus C, that is equal to A plus and then B plus C in parentheses. So you see how the parentheses just moves from being around the A plus B to being around the B plus C. So that's the first 2 numbers and then around the second 2 numbers. So that is an example of the associative property. Okay. Let's go to number 3. So number 3 says -9 plus negative 7 is equal to negative 16. Okay. Actually, hold on. Let me make sure I'm saying this correctly. Okay, just a second. Yeah, this is, we have negative 9 plus 7, and that is equal to negative 16. So when you actually take these two numbers and you add them together, that is the closure property of addition. Because you're creating closure, that when you add these two numbers together, it gives you a single number. So that's your closure property. Fourth one is 45 plus 0 is equal to 45. And I think I'm actually going to need to go back up here to the identity property. I mislabeled this one. Sorry about that. This one is the inverse property. So when you add a number and it's negative to get 0, that's called the inverse property of addition. Whereas if you take a number and you add 0 to it and you still get that number, that is the identity property of addition. So the identity property is a plus 0 is equal to a. So that's how we have a is represented by 45 in this example. So 45 plus 0 is still equal to 45. Okie dokes. And the last one, number 5, is 9 plus negative 6 is equal to negative 6 plus 9. So here we have an example of the two numbers staying the same. We still have a 9 and a negative 6, but they're in different orders. So this one commuted over here, and this one commuted over here. So this one's called the commutative. You know, like when you commute somewhere, it's like you have to drive somewhere else. So these are they're in the different order on the other side. So commutative property is number 5, and that one is represented by a plus b is equal to b plus a. So when you just switch their orders, that is the commutative property. Okay, so I think that completes the problem that you sent. Thanks for that request. And let me do another multiplication example. Let's do, had a request for 7 times 40. Absolutely. Okay, so we have, our problem is 7 times 40. So let's write the 2-digit number on top. So that would be 40 on top, and then 7 on bottom. Make sure that you line up their ones digits. So the ones digit of 40 would be the 0. and the tens digit would be the 4. So we're lining up the ones digits, because if it's just a single number, then that has to be a ones digit. Line up the ones digits. Okay. So now we multiply the ones digit on bottom by every digit on top, starting with the ones digit. So we start by doing 7 times 0, and we place that in the ones digit below the line. So 7 times 0, anything times 0 is 0. So we put that down below the ones digits. Now we're going to multiply the 7 times the 4. 7 times 4, what is that? That is 28. So we always put the ones digit down below. So let me write it out here. 7 times 4 is 28. So we start by writing the ones digit of the answer under the top number. So that 8 would go here. If we had another digit here, we would carry the 2, but we don't. So we just bring it down. So 40 times 7 is 280. Another way to think about that is if you're ever multiplying by a 2-digit number that the second digit is 0, you can just do the two numbers together and ignore the 0. So 7 times 4, which we said here was 28, and then we add the 0 back in at the end. So we just put the 0 behind it, makes it 280. That's another way to think about it when you're multiplying a two-digit number times a one-digit number, that the two-digit number, the ones digit, is a 0. Any questions on that one? Or did you have another problem that you'd like to work on together? I know there's a bit of a lag, so let me go ahead and just give you another example problem. So just give myself a little bit more room here, 1 second. What if we were going to do 60 times 8? I should write it out like this. 60 times 8. So the first thing we want to do is to line up the ones, put the two-digit number on top and line up the ones digits. So 60 times 8. And then we take the ones digit, multiply ones digit on bottom, multiply it by the ones digit on top. So that would be 8 times 0. Anything times 0 is 0. And then 8 times 6. 8 times 6 is 48. Let's come over here and write that down. 8 times 6 is 48. So we take the ones digit of that answer and put it below the 6. That would be the 8. And then if there was another number here, we would carry the 4, but there's not, so we just bring it down. So 60 times 8 is 480. Or again, we can take our 8 times 6, just drop the 0 for the moment. 8 times 6 is 48. Then add a 0 to the end, makes 480. And it gives us the same answer there. Awesome. Is that clear? Did you have any other questions you would like to work on? Can we do it another way? Another way other than what we've done so far? Sure. So the 60 times 8, we can do it similarly like we did the 10 times 20. So since we're doing 60 times 8, we take the larger number and add it up the smaller number of times. So we're taking 60, we want to add that up 8 times. So that would be 60 plus, that would be 160, 2 60s, 3 60s, 4, 5, 6, 7, 8. Now that's a lot of 60s to add up, so we could do that, but it would take us a while. But that's okay. We can add these up. So to add these up, maybe we'll add them up in groups. It's like these two 60s, we could add them up to make 120. These two 60s, we could add them up to make 120. These two would make another 120. And these two would make another 120. And then in that same kind of vein, we can continue by adding these two 120s. 120 plus 120 is 240. So 240 plus another 120 plus 120 is again 240. Then lastly, we can add up these last two 240s. 240 plus 240 is 480. So that's 3 different ways of multiplying 60 times 8. Does that help? Might need to think about it a little while, but you can always come back and rewatch the live stream later on to help it sink in a little bit more. You bet. 5 times 80. Sounds good. Let me give myself a little more room down here. You can do this one in all 3 ways if you like. Just do this. Okay, so we want to do 5 times 80. So the first method we talked about is putting the 2-digit number on top. That would be the 80. The 1-digit number on bottom, lining up the 1's digits. So that would be the 5 underneath the 0. Put our multiplication sign and draw our line. Now we want to multiply the 1's digit that's on bottom by every digit on top, starting with the 1's digit. So 5 times 0, anything times 0 is 0. Next we move on to 5 times 8. 5 times 8, let's write that out here. 5 times 8 is 40. So we put the ones digit of that answer, which is a 0, below the 8. And then we would carry the 4 here if we had another number, but we don't, so we just bring it straight down. So 8 times 5, excuse me, 80 times 5 is 400. Yeah, for sure. What problem does your brother, if your brother wants some help as well, he can feel free to post his question, or he can let me know if it's a question that I already had. I'm not sure, because I did already do the properties problem, but I can go over it again if he would like. So yeah, 80 times 5 is 400 in this way, or we can say that we know that we can just take this 8, drop the 0 for now, just do the 8 times 5, that gets us 40, and we add an extra 0 on the end, so that gives us 400 as well. Or we can use the strategy of adding up 80 5 times. So that would be 80 plus 80 plus 80, that's 3, 4, and 5. So let's add these together in pairs. 80 plus 80 is 160. Another 80 plus 80 is another 160. Then this 80 doesn't have a pair with to add with, so we'll just drop them down. Now we'll add the 160 and 160. That's a little harder to do, so bring it over to the side. 160 plus 160. 0 plus 0 is 0. 6 plus 6 is 12. Put down the 2, carry the 1. 1 plus 1 plus 1 is 3. So that would be 160 plus 160 is 320. Then bring down our plus 80. Now we have 320 plus 80. Let's bring that out to the side. 320 plus 80. Oh, can you see that? Oh, you can't quite see that. Yeah, you can always just add the numbers together. The number of, add the larger number together, the number of times you're multiplying it by. It's just, that is what you're doing really. But sometimes it's easier to just multiply it out in the way that I did it at the beginning, because if you're multiplying really big numbers, this is gonna get difficult to do. When the numbers are too large. Okay, so 320 plus 80, add the 0 plus 0 is 0, 8 plus 2 is 10, take down the 1, sorry, put down the 0, carry the 1, and then 3 plus 1 is 4. So we still get 400 in all three methods of doing this problem. All right, is that clear? Did your brother have a question that he wanted help with, or was that the property question that I did before? Wow, this is a lot of lag. You still there? Okie dokes. Well, I'm not sure what your brother was wanting, which question your brother was wanting to ask. We did talk about, I went over this matching the statements with the properties. I did that before, but he may have not been logged in at the time. Is that what you were wanting? So give me just a moment to check on another problem. Okay, so I have this problem of write the equation of a line perpendicular to y equals 2x plus 2 that passes through the points -1, comma, -7. Okay. Make sure you guys can see all of that. Yeah, you sure can. Okay, great. So if we want to write the equation of this line, we first of all want to recognize that perpendicular lines have negative reciprocal slopes. So if we take this equation, y is equal to 2x plus 2. If we take this equation, we need to identify the slope. So the general form of an equation of a line is y is equal to mx plus b, where m is the slope and b is the y-intercept. So the slope of this line is 2. So we're going to take that 2, but we want the slope of the equation of the line perpendicular to be the perpendicular slope. So we take the reciprocal, which means we flip over the fraction. Any whole number is written over 1. So the fraction of the reciprocal of 2 would be 1/2. And then it's the negative reciprocal, so we need to put a negative out front. So the slope of the line perpendicular to this line would have a slope of negative 1/2. Once we find that slope, we can plug this into the point slope form of a line, which is y minus y1 is equal to m times x minus x1. Because we have this point given, which is -1, -7. This would be our x1, y1. And our slope we just found to be -1/2. So if we plug that in, we get y minus -7 was our y1 is equal to -1/2 times x, we leave x as x, minus our x1, which is -1. Plug that in there. And then I give myself a bit more room. So we distribute these negatives to get a negative times a negative is a positive. So that's y plus 7 is equal to -1/2 times x. Again, a negative times a negative is a positive, so x plus 1. We distribute our -1/2 in, so y plus 7 is equal to -1/2 x, and then -1/2 times 1 is -1/2. Then we want to finish solving for y. We do that by, we have a plus 7 here, so we need to subtract 7 on both sides. So this plus 7 and the -7 cancel out. It gives us y is equal to -1/2 x, and then we have -1/2 minus 7. To simplify that, we need to find a common denominator. And yes, I just saw your question, and we can definitely go over the order of operations. Absolutely. So just give me 1 second, and I'll be finished with this problem. Find a common denominator. The denominator of 7 is currently 1, so we multiply top and bottom by 2 to get y is equal to -1/2 x minus 1/2 minus 7 times 2 is 14, 1 times 2 is 2. So then once we have common denominators, we subtract, or we combine the numerators. That gives us y is equal to -1/2 x minus 15, and the denominator stays the same, over 2. So this would be the equation of that line. Okay, so feel free to let me know if you have any questions about that problem, but I'm going to go on. You can't hear me. Can you hear me now? Let me give myself a little more space to work on order of operations. Okay, wonderful. Great, so order of operations. So the general form of order operations is parentheses, exponents, multiplication, division, addition, and subtraction. So we can write that. Okay, beautiful. So we can say that this is PEMDAS, or some people say BEDMAS because you, instead of using parentheses, you use brackets, however you want to say that. So this is parentheses. Do those first. So you simplify inside of a parentheses first. Then you want to take care of your exponents. Second. Then multiplication. And let me know, by the way, if you have any specific problems. Otherwise, I can just make some up. But if you have a specific problem, then that would be good to do together. D stands for division. A is addition. And S is subtraction. Okay. You can hear me talking just barely. Okay, let me turn my mic up. Okay, I've turned my mic up now, so let me know if you can hear me any better now. Testing, testing. Can you hear me? Hello, can you hear me? Testing, testing, testing. Okay, well, I'm not getting a response, so I'll just keep going. So we have parentheses, exponents, multiplication, division, addition, and subtraction is the order that we want to go in. So for example, if we have the problem 3 times 9 plus 7, we have two different operations that we have here. This operation is multiplication, and this operation is addition. So my order of operations says, do I have any parentheses? No, so I skip that. Do I have any exponents? No, so I'll skip that. Do I have any multiplication? Yes. So I want to do the multiplication first, before the addition. So 3 times 9 is 27. So I will do the 3 times 9 first, then I bring down the plus 7. So the 3 times 9 was 27, and then bring down the plus 7. From here, we only have one operation left. So once we have one operation left, we know which one it's going to be. It's going to be that one. So 27 plus 7 is 34. And that would be the answer to that problem. Is that clear? Can you hear me now? I'll do another one for you just in case. What if we have 12 plus 36 divided by 4? So we have two operations. Two operations that we have here. One is addition and one is division. So which one do we come up on first? No parentheses, no exponents, no multiplication, but we have division. So we need to do division first. 36 divided by 4 is 9. So we do the 36 divided by 4 and then bring down the 12 plus. And 12 plus 9 is 21. And that will be our final answer. You're pretty sure this is not order of operations? Can you give me an example problem? Sorry. Can you give me an example problem of what you're doing? Because this is order of operations. Yeah, sure do. Like what's a problem that you did on your homework recently, or a worksheet recently that that you weren't sure of how to do it? You're welcome. Okay, so let's see. If this isn't what you're doing, what could you be referring to in terms of order of operations? This is what order of operations is, so I'm not sure exactly what you're referring to. So if you can give me an example of a problem that you are working on, then that would be really helpful to try to answer your question. Well, we have been going on this live stream already for an hour now, so maybe if I don't get a message from you shortly, maybe we can continue tomorrow and try to send me some practice problems that you're working on for tomorrow's live stream. Hold on 1 second. Looks like I might have a message being typed. Hold on just a minute more. Okay, so I just got a practice problem for you. That what you're doing is problems like 9 times 4 in parentheses plus 15 minus 7. So let's go through this one really quick before we call it a day. So we want to look and see what are all the things happening here. So we have a set of parentheses. So we always want to do what is in the parentheses first because it comes first in the order. So let me write my order down. Okay. Oh, that was much better. This one's actually harder. Okay. Cool. So we start with what's in the parentheses because parentheses comes first. So what's in the parentheses is 9 times 4. 9 times 4 is 36. So we can bring that down. And once we've simplified what is inside of parentheses to one number, we don't have to write that parentheses anymore. So that comes down as 36, and then plus 15 minus 7. So now we have two operations left, a plus and a minus. So in the order, A comes before S. So we want to do addition before we do subtraction. So let's do 36 plus 15. We'll come over to the side. 36 plus 15. 6 plus 5 is 11, so put the 1 down and carry the 1. 3 plus 1 is 5, so 36 plus 15 is 51. And then bring down the minus 7. Then we want to do 51 minus 7. So write that down, 51 minus 7. We can't subtract 1 minus 7, so we borrow from the 5 to make it a 4, which makes that an 11. 11 minus 7 is 4, and 4 minus nothing is 4. So 51 minus 7 is 44. Let me know if you have any questions on that problem. Or if you would like to do a different problem. Oh, and you couldn't quite see my addition over here, but there you go. Now you can see it.